is taken into account. How? Why did I say that work has been already taken into account? Owing to the fact that VR is now 0. There was VR initially, which now reduces to 0. When was VR seen? Just before tension did show. VR was seen. Now when tension shows, VR is not seen. Correct, dear?
Yes, sir.
VR was seen just before tension shows. Now when tension shows, what it does, it reduces VR to 0, right, Krish?
Yes, sir.
So now tension has done its bit. Tension has done its bit. And what was it to do? It was to reduce VR to 0, right there?
Yes, sir.
So it is a spent force now. It is a spent force now. Tension, whatever it was to do, it being done and dusted. Now, is the string out? Yes, it is. Agreed?
Yes, sir.
So string is out. What speed is left with you is only Vt, correct?
Yes, sir. Yes.
What speed is now left with you after of tension show? After of tension show, what speed is left with you is only Vt, correct?
Yes, sir. Yes.
And what is Vt equal to? You know, under root of GL cos 30 degree, correct?
Yes, sir.
Now my question be that if there is tension which will be there now through and through, and if there is V equal to under root of GL cos 30 degree, and is also acting gravity on the particle, can I conserve my energy from this position after of tension being operational? Clear?
Yes, sir. Yes, sir.
Yes.
Can I conserve my energy from this position after of tension being operational to this position? Yes, no.
Yes, sir.
Yes, sir.
Yes. Now we can. Now we can. Why? Because whatever tension was to has already been taken into account. So this is being removed. This being removed, it is an organic case to you. What organic case? There is a string which is at a certain angle with the vertical, 60 degree with the vertical, and you let it loose with the speed GL under root cos of the angle 30 degree. Can you conserve energy? What will you say? Will you or not? Tell me, dear.
Yes,
We
sir.
can. Because work done by tension is 0.
0.
How is it 0? Tension and displacement, they are all to be perpendicular given any point in time, correct?
Yes, sir.
So we can conserve energy from here to here. Please write the conservation equation. What will it be? Minus of, tell me, minus of mgl by 2, correct?
Yes, sir.
Yeah.
Yes.
Plus of half m, which we, shall I take under root of GL? Shall I take under root of GL cos 30 or under root of GL cos 60? What shall I take? Come on, tell me.
Under root of GL.
How can I take under root of GL, Krish? What are you saying, Krish? What are you saying, Krish?
No.
Is under root of GL speed with me? Then what is the point taking conservation half base? Then you can take conservation from top to bottom, correct? Yeah.
Yes, sir. Yes, sir. Yes.
So what will be energy there? Plus of half m, which one?
VT.
Vt. So I am writing Vt only. Vt square is equal to, now with position, this position. So what will be energy there? Potential minus of mgl and plus of half m v prime square. Correct? V prime is the speed there. Find yeah?
Yes, sir.
Tell me what will be v prime from here. Quickly find it out, all of you. Tell me what will be v prime. What are you getting v prime equal to? prime, you can take under root of GL cos 30, you can place a value. VT square means GL cos square 30 degree.
Sir, I'm getting under root of 7GL by 4.
GL by 4. Can be.
1 second.
If I get one more subscription, I can go for it. It can be. Under root of 7 GL by 4. What is your calculation to say, Adesh, Vedant?
So under root 7GL by 3.
What is it?
So under root 7GL by 3.
7GL by 3. Okay.
I'm just getting under root 7GL.
Come on. 3 people are getting me 3 answers. I don't know which one is right. You can figure it out. Okay. Now write down. This is the question now. Okay. Over here. Just a minute. Now over here. Work done by tension. Okay. But then you will ask me, sir, just now, a few seconds back, few minutes back, you did say that there is no mass with string, so you cannot associate energy with spring. I'll say I am not taking departure from it. I'm still sticking my neck out on it. Of course, there is no mechanical energy which you can associate with it, but you can associate vibrational energy to it, correct?
Yes, sir.
Okay, so what we are to say, energy is getting lost in the form of electromagnetic radiation, because this is a safe word which in itself entails all sound energy, light energy, and vibrational energy. Is it okay?
Yes, sir.
So we will say, yes, the string will vibrate, and you can see that vibration. If you exhibit this practically, you will see string will start vibrating. So there is some energy which is associated with vibration. Therefore, we say vibrational energy. There will be a whisk sound as well. So we can say equally good is the amount lost in electromagnetic radiation. Correct, dear?
Yes, sir.
So that is the reason we are to say there is a loss in the form of electromagnetic radiation. We don't associate mechanics with massless string. Clear, dear?
Yes, sir.
Remember, this will always be the case. Whenever you have impulsive force, by impulsive force I mean impulsive in nature, out of blue it acts. Is it okay? Right, from shot from it came, as shot from blue it came. At the drop of a hat it came, and accordingly it go by. It go past you. Is it okay? So a very short moment of time, if a force is to act, then we associate impulse with it. We say that person is impulsive in nature, right? Yeah.
Yes, sir.
So impulsive in nature means it will not be giving much of a thought to process. It will react more than respond. Correct?
Yes, sir.
Impulsive in nature. So what I'm to over here suggest you, which I'll be making very good. In fact, this is a theory which you have to study, and quite deep-rooted theory when you are in conservation of linear momentum, which is a very important topic as I've already had. Now, conservation of linear momentum will establish whatever I'm telling you over here with the help of coefficient of restitution. And what will it establish? It will establish that force which are impulsive in nature, force of forces which is oblique are impulsive in nature has oblique have tendency to do work in no time. Okay, if a force is impulsive in nature, it can do work in no time. For example, you throw a ball to wall. Is it okay, dear? The speed v with which you have thrown the ball and speed v with which what it hits the wall. But while returning, you may not be sure of what speed it is returning with. It can return with speed v. It can return with speed less than v, or it can return with speed greater than v if the particle is super elastic. but that doesn't happen in general. So either we are to get it returning with same speed or returning with speed less than that. That means what happened during the course of collision, some energy was lost, correct, dear?
Yes,
Yes,
sir.
sir.
And that energy loss, if I'm to attribute to any force, I'll be attributing to the force that wall is applying on the ball, correct, dear?
Yes, sir.
So remember, impulsive force, that force which wall applies on ball is impulsive again because it acts for a very short period of time, correct?
Yes, sir.
Just write somewhere in a scripts. I'll be coming back to this concept later. And it's a very important concept you don't get to see in books or packages, except for one book. I'll not name them. Name that. But for now, I think you will be absolved of any book flip if you write somewhere and highlighting that point. Impulsive force can do work in no time. Impulsive force can do work in no time. So in no time of its operation, in absolutely zero time or tending to zero time of its operation to be practical, it can do work. It doesn't require time for work. Any force you take, gravity if you take, it requires time to do work, correct, dear?
Yes, sir.
And gravity can immediately change velocity or speed? No. It requires time to do. So that is non-impulsive. But the forces which are impulsive, a ball being hit by bat, what happened? It is impulsive. Why? It changed the momentum of ball in no time, correct?
Yeah,
Yes.
yes, sir.
So any force which can change momentum, which can change velocity, is called in no time, is called impulsive force. And impulsive force can do work in no time. That is what you realized over here. Tension which suddenly did pop. Tension was not to be seen before of this position, correct? Yeah?
Yes, sir.
Tension was in absentia. Tension was in absentia, but it did pop. The moment it popped, what we have to say? We have to say tension is acting impulsive. Why I'm saying tension is acting impulsive? Because tension did change momentum. Agreed?
Yes, sir.
What did tension do? Did it change momentum in the radial direction? Yes or no?
Yes, sir.
Yes or no? Which force did change momentum in radial direction?
The
Can we say
tension.
gravity did momentum in radial direction? No. We
No.
cannot say gravity. Why? For gravity to change momentum, it requires investment on time. Clear?
Yes,
For
sir.
gravity to change momentum, it requires investment in time. Gravity force is not an impulsive force. It cannot change momentum in zero or tending to zero time. Clear?
Yes,
Yes,
sir.
sir.
So which force can change? Whichever force which is possible for force to change momentum in no time is called an impulsive force. And tension over here did change momentum and it happened in no time. Therefore, what kind of force is tension? Tension is impulsive force. So impulsive force do have tendency of doing work in no time. Impulsive force can do work in no time. Is it okay?
Yes, sir.
Okay, good. Two questions which I am giving for you as food for thought. Question number one. Two questions as food for thought. Question number one. Two particles, each of mass small m. Two particles, each of mass small m. Just fit, just fit in a narrow hoop of large radius r. Just fit in a narrow loop of large radius r. If mass of hoop is capital M, if mass of hoop is capital M, then first task, question number 1. Can we realize a situation? Can we realize a situation in which hoop breaks from the ground? Can we realize a situation in which hoop breaks from the ground? What comes to you? I take in piecemeal. Let me ask you on this, your take. Tell me, Adesh, what comes to you? Is it a possibility to reckon? Is it a possibility to reckon, or you will be dismissive of it, you will loathe it? Will you loathe the possibility of hoop leaving ground, Adesh?
Hoop.
Yes, Adesh.
Yeah, so I'm just reading the question once again so that.
This is a hoop, a narrow hoop. That means this constriction is very narrow, and two particles are just fitted in it. Two particles are just fitted in it. Means the particles are touching in a way both inner and outer surface of the hoop, but they are touching more the inner than the outer. There is no space between the surface of particle and hoop. They have somehow got accommodated inside. Clear, dear?
Yes,
Here
sir.
are they. And now, after all they getting accommodated, what we do? We let loose. We let them move. And if we let them move, they are now moving inside of the hoop. They move by whatever distance they deem they can. By distance, I mean the angular displacement. They can move by any angle. They can move by any distance on the periphery. What I'm simply an ask on is, does it cut eyes with you? Does it bode well with you that there can be a possibility when hoop leaves the ground? Does it augur well with you?
Sir,
Or
isn't it
your
similar to the previous question? Sir,
yes,
sir, isn't it like kind of similar